the happenings for this course. Yeah, once we are done, then we can then proceed. I'd like us to just pray, and then now we let us, and then we just continue with the rest of the meeting, particularly on the things that I wanted us to just talk about in our closing meeting today. Just want to, as we do that, just want to encourage you that every good things you carry, everything about yourself is in your heart. Everything you require in life is in your heart. All the things you intend to achieve in your life, every decision you make starts from the heart. And that's why you need to live from your heart all the time. We need to learn from our hearts. We listen to what is in the heart, because that which is in the heart, that which is in the heart, nobody else can see apart from you. And I think if you can connect that to the scriptures in the book of Luke 6:45, very popular verse, Luke 6:45. Let me just pull it up so that as we start the session today, we are aligning, even as we do the parting shot for the semester. Just want us to reflect on that. That is the NIV. You can read other versions also to get a deeper interpretation of that message, that everything really starts from the heart, whether good or evil, it is registered there. So it says that a good man brings good things out of the good stored up in his heart. And an evil man brings evil things out of the evil stored up in his heart. And from the mouth speaks what the heart is full of. So I think I just want us, as we wrap up the semester, reflect on the importance of what it is that we cannot see in you, because that which we cannot see in you is in the heart. It is not in the physical. And so as we think about the human hearts, which is the recreated human spirits, it reminds us that everything just surrounds the heart. And so that heart would now inform what is in that human body, which is God's temple, as we reflect on it. So as we dwell, I would like us to think of those good things that should be nurtured and raised within us, so that as we speak out, we speak exactly that which comes out from our hearts. And so we emphasize on the first part of the good things that dwell in our hearts. And so can we speak of those even as we engage in other things? So I just thought I could remind ourselves as well that people see what is in the physical, but that which is not in the physical is in the heart. And so ask ourselves, what is in our hearts? And so you're required to reflect and think about it, because that is what makes us. So that is a message not just for you, but also for myself, because out of the abundance of the heart, then the mouth speaketh. So that is a good way to end the discussions we've been having all through from the beginning. And I thought it could be important that as we go and we part in this particular class, reflect on those good things that we need to really reflect from what we speak, because those are the ones that come from our hearts. Good, thank you. I thought that will be useful for us today as we proceed. Good, now let's then engage as we pray. Let's pray first of all. Let's pray. Father, we want to thank you for this particular session you've given us. We thank you for the journey that we've walked with the students from the beginning of the semester till today. As you do the wrap up, we want to pray that, Lord, your guidance shall follow follow us even as we engage in other things that are about to happen for this month. And even as we think about the end of the semester, we are seeing the good things you've done for us. Even as we depart, even after today, want to pray that you help us so that we can nurture those good things in our hearts, those that will glorify you, because our bodies are your temple. I want to thank you for the session you're beginning. Guide us and be with us, for we pray in Jesus' name. Amen. Good. Are we there?
Amen.
Good. Nice.
Amen.
Hallelujah. So let's proceed. Then class rep, anything from your end? Are we good?
Yeah, we are good. We are good.
Nice.
We can continue.
We can proceed. Now, I wanted us to just do a very brief a review of some aspects that we had not touched on when we did, particularly hypothesis testing. We have completed the content as per what is scheduled to be done for this unit. We have I've exposed you to the foundational knowledge in statistics, areas of application for research, which I hope they will find relevance in what you're doing, not just in research, but also in your day-to-day lives. So I'd asked you to get the data the data set that you used earlier when we did hypothesis testing. I think there were one or two things we had not completed by that time, because we wanted to also catch up with the other aspects of correlation and regression and the like. Yes, so this is the data set. I hope you all have it somewhere. I hope that is visible. Yeah, please note that we have already covered aspects of regression, correlation, interval estimation, and the like. Another section that we were yet to complete, I'll just give you highlights on conducting hypothesis testing, part 2 for the use of, for those using Stata, and also an idea of the same with Excel, so that for those of us who don't have a Stata, then you are equally armed to conduct hypothesis testing, some basic ones, depending on the research question at hand, then that is also visible. So I think if I remember correctly, this column is one we ought to remove. Let me just delete the column labeled type because it's a repeat. This variable is also gender, so I don't have to have this one. Although, yeah, I think that is the data set. So if you have your own, you can delete that particular column. Yeah, so mine is just to guide and think of hypothesis testing and see how we're going to interpret those tests. So maybe if you want to just go back a little bit on the material that we covered when we did hypothesis testing. So these were the things we did together. We considered the basic principles of hypothesis testing. We created the context. This was the time we did this lesson. So I'm encouraging you to have a preview of that lesson from the recording, so that as we complete the exercise, then it can be complete. So towards the end, we had demonstrated the use of parametric tests, and this is what we wanted to just show. So we had done this. We are using the data set on students' achievements, and we wanted to just demonstrate some of the techniques as we use either Stata or Excel. So that data set is labeled as such, and I hope you can still remember the variable names. The first variable there is score, which is the mean score out of 12 for a sample of, let me get the total number of students in here, 200 of them. So data set for 200 students. And then the first variable is the scores. This is the household size, how many they are in the household. This is the gender for the student. This is the region, which is the region in which the student school is based, where it is located. I think this is the number of years of the parents' education, the average years of education for their parents. That is, dad, mom, do an average, or simply one of them, if that is the case, whichever case is applying. And then we have the scores in the languages, combined average for the languages. We want to see whether the languages scores is a predictor of the overall scores. So that can be a type of a research question to be answered. Or we can as well conduct hypothesis tests to see whether there's any differences in terms of the average scores in total and the average scores in languages. Alternatively, the other question you can also ask is the average scores different across gender? Are the male students performing better than the female? Or even in terms of regions, is there any differences in terms of the average scores across regions? Remember, the region has three particular indicators there, or three regions. We have we have those from the north, west, and south. Those are the three regions. So we just wanted to, I'll demonstrate briefly in Stata, and then I'll also attempt with Excel, so that we are well armed with the requisite tools for conducting hypothesis testing. So let's have some questions to first of all ask. First of all, let's just a moment, sorry. Good. So let's have some research questions that we want to address. First things first, just want to ask the following, or test the following: that is there a difference? Is there a significant difference in mean scores? A, Roman 1, between male and female students. Two, is there any difference in the mean scores across regions, across the three regions? That is, schools in those three regions, north, west, and south. So maybe you can begin with that one. Then if there will be alternative tests, then we can as well suggest. But I'd like you to also remember the principles of hypothesis testing. Means that we just first of all need to have an hypothesis to be tested. So I'm copying the data set, just complete data set from the first observation to the 200th observation. Let me just copy. I've copied the data set. I want to load them into Stata, and here we go. So I'm opening Stata. So for now, we're just, because it's demonstration, we're just using the shortcut procedure of copy and paste. So let's paste the dataset into the editor, which you can see right in here. Click on the data editor right there. From there, we can paste. I've just clicked paste, but then we have the second option for treating the variable names, the first row as variable names, because that is exactly how it is labeled. So having done that, then we can safely even close it. There's no problem, because the variables have been loaded, as you can see right here. I think up to there, we have no issues. So what we wanted to know is, how do you go about conducting hypothesis testing using various options that we do have in. I prefer the Stata option software, because it's more flexible. It gives you more options. It's a bit easier to work with. The one for Excel, you might need to just rearrange the data set in a certain way, so that by the time you execute the test, you're able to really I've prepared the data to be suitable for the same. Someone's raised their hand, Juliet. Yes, Juliet.
Hello.
Yes, proceed. We can hear
Can
you.
you hear me? Okay.
Yes.
If you don't mind, can you repeat from the start, like copy pasting the data, then pasting in the data?
Okay. First of all, I hope you do have the data set right here. Do you have the data set?
I have.
You have it, right? This is the data we used when we had. So I want to believe this is the data set you do have. Let me just close this one completely and then we begin the process. So I want to hope that the data is highlighted for the person that was asking. All of the data set include up to the last observation. Yes, can you confirm that it's highlighted for your case?
Yes, I am highlighting.
Okay, please do that. Once you're done, let us know.
Okay, I have highlighted.
So open your data, which I believe it should be like this.
Yes, I've done that.
So go to the editor right in here. The editor is what I'm pointing from my end. Just click it once. The spreadsheet will pop out. Hope you have that one.
So
From here,
I paste there. I click paste.
yeah, click paste.
Okay.
Then you pick the second option for data arranged in terms of the variable names appearing on the first row. Are we done?
I'm not getting that one. I'm not getting that one. When I pick paste, it's just coming to command.
What is in your, do you have then the variables? If you've pasted, do you have anything on the variables window here? Well, are you able to share your screen though?
No.
Can you share
Yes.
your screen so that we fix your problem
Okay.
once and for all? Yeah.
Okay, so I have found it, Daktari.
Okay, perfect. Thank you. All right, so there we go. So let me go to the editor for my end. I have pasted the data set and you have it complete. So these are the data sets. So I want us to just locate the hypothesis testing menu. Let's do it from the drop-down menus available in Stata. And all these are available under statistics, as you can see right in here. So we're going to do parametric tests. So statistics. So you go to summary, tables, and tests. They're all there. Summary, tests, and tables. From in here, you can have the classical test of hypothesis. So classical test of hypothesis. So let's just repeat the one that we had done the previous time, last time. You can do the one sample mean, let's do one sample mean comparison test. So let's click on that one. And the question you're asking there is, it is claimed that the average mark is, say, the average mean score is 6.5 in the region. So I click on that one. Then the options, the window pops out for you to have the options in Stata. Click the variable of interest, which is the score. Click on that one. You are picking the dependent variable, for this case, score. And then select the hypothesized mean value. In this case, let's just work with 6.5. So here, suppose it is indicated in the national report that the performance in the entire country is 6.5 for the whole country. But when you look at the results from this county, which you've selected 200 students, you have the data set that you've been given in Excel. Suppose this came from your county, but then the national figure is reported at 6.5. So you'd want to know whether the county performance really matches what is being reported nationally. So in this case, the hypothesis is that the hypothesized mean value is 6.5. And so you want to test that against a 3 different alternatives. So I can click OK because we're not going to come back to this one. Click OK. Then now we have the numbers there. So we concentrate on this is the command. So we can now get that as the command for hypothesis testing. So the hypothesized value is this one. The mean is equal to 6.5 against 3 alternatives. So as we mentioned last time, if you're doing a two-tailed test, then you interpret the results in the middle. So this means that the null here, the alternative says the mean is not equal to 6.5. So we focus a lot more on the p-values to interpret the meaning of that particular result. So let's interpret the middle value here, the middle statistic reported in here. So the p-value being greater than, or rather being less than the conventional 5%. If the p-value is more than 5%, if the p-value is more than 0.05, in other words, then we do not reject the null. So that is what we've said. We said during the theory, the discussion we had in class. In our case, the p-value is 0, actually 0.00. So there's actually overwhelming evidence against the null hypothesis. So in this case, since it's less than 5%, then we have a sample evidence that the mean is different from 6.5. That's okay. So if that is your hypothesis, then this concludes. So ideally, one would expect that you pick on the type of test you want to run. Let's look at the other one just to illustrate. This other one tells you now you modify you'll have to modify a little bit the null hypothesis, and say, for example, here the hypothesized value is 6.5 against a value or a mean value of 6.5 and above, or rather more than 6.5. So in this case, the p-value is still also 0.00. So it means that you also have evidence against the null hypothesis. So you reject the null in this case. So which means that actually the true hypothesized value as per the sample is higher than what is being hypothesized. So that is how we'll go. So let's now look at our problem at hand. We want to assess whether there is a significant difference in the mean performance across gender. So someone is asking if it's possible that I take that again. Yeah, the good thing is that the recording will be there as well. So that can also give you a confidence that you can pick it up. No, so but just for us to pick it from the session here, we're saying the following, that you have an hypothesized value of 6.5 against 3 different alternatives. So we've interpreted the middle one, which is what we're saying, that the alternative is the mean is not equal to 6.5. So what you can do then here is we can then have your null saying that the average mean score is 6.5 against an alternative indicating to us that the average mean score is not equal to 6.5. So rule of thumb is that whenever the p-value is less than the conventional 5% level, or rather 0.05, then what that means is that the tests, or rather you have evidence from the sample, again, that favors the alternative. In other words, you have evidence to reject the hypothesized your null hypothesis in that case. So I think I have repeated that case. So for the person asking, all we want is what does the p-value tell us? In this case, it is 0.000, which tells you that there's overwhelming evidence from the sample collected that indeed the mean is different from 6.5. I think that was what someone is asking that I clarify. Francis, can you proceed?
Hello, doctor. You mentioned my name.
Doctor, you're muted.
Yes. Francis, can you confirm that you are we okay with Francis' question?
Doctor, it's not me who asked. Could have been somebody else.
It was someone else. Oh, then it's okay. Then let's proceed. I think that is sorted. Now let's proceed. So let's now do the one that we had proposing here. So you want, suppose nationally it is claimed that overall there's a difference in the performance of male and female students. Or someone may say, well, female students always perform better than the male students. So the hypothesis can be asked in different ways. So what you can do here is we can have a different hypothesis. But let's stick with one of them. So the mean difference is equals to 0. In other words, the performance of the male students is equal to the performance of the female students. So there's no difference in terms of their performance. So remember the way we said that the null hypothesis is often framed in the status quo situation. It means that there's no, we often bring it, or rather bring it out in the sense that we do not have any significant difference, or you are in the negative state, or the status quo states. And that's why we're saying that the mean difference is 0. Against an alternative that the mean difference in terms of their performance is different from 0. So what tells you that the performance of the male students and that of the female students is different. So if this is a hypothesis, then you now go back to your data set, go to statistics once more, classical test of hypothesis, where we were, then we could now pick on the one for the 2 group. Yeah, 2 group. So there you can now compare performance across gender. So I click on that option. Your variable is the same score, and then you have the grouping variable, which is gender in this case. So I select gender. So there you can compare. And then the flexibility, one of the flexibilities with Stata is that it all gives you an option to see whether you are assuming equal variation in their performance or there's a difference in the variation. So we could as well go for the unequal variances, because at times different, the averages or the scores could be different even across different students, whether males or females. So we can for an unequal variance. Then once you are done, you click OK. Equal variance. So there's really nothing much to talk about, because these are about the descriptive statistics like before. But remember, your test is right down here. This is where you are. operating in. So I want to interpret the middle value here, that there's no significant difference in this case against the significant difference. So I'm looking at the p-value here, and I have a value of 0.2911. So having said that, I would like one of us to interpret, now that I did the first one, what does this mean for our null hypothesis? One person, one of us to make a comment. I want someone to interpret this test, statistical test result. Before I nominate a volunteer, nominee, or I pick a name at random. Yes, Paul, thank you.
Mwalimu, if I may try, we reject the null hypothesis.
Reject the null hypothesis. Yes. Is there a reason why we reject?
Because the p-value is greater than how do you call it, the hypothesis.
It's greater than 0.05. It's always remember the conventional level is 5%.
5%.
Okay. All right. Yeah. Let's get any other opposing view. Can I get another person to say something? Yes. Okay, Cindy.
I'm just trying, Daktari.
Yeah, that's why we are here.
We said if it's less than 5%, we reject, but this one is.
It is.
It's. Are we interpreting the 0.8545 or it's 0.2911?
That's 2911. The one that is highlighted, 0.2911.
Okay, we reject because it's less than 0.5%. No. We don't reject. Huh?
We don't reject.
We don't reject. Yeah, we don't. We don't reject.
Okay, let's have that was Cindy, right?
Yes, it's more than this is more than 0.055.
Okay,
yeah.
Fine. Someone else, I think Mogere wanted to break the tie now. Mogere, wrap it up for us.
I wanted to say that that being 29%, which is obviously more than 5%, so we don't reject the null hypothesis.
We do not reject. Okay, so you are siding with this last presenter. Okay, Paul Amata, I think your result of rejecting, okay? Yeah, you just need to pick it up from here. Yeah, we are here to learn. So there we go. If you pick from here, the p-value less than 5% implies we reject.
Okay.
In our case, it is not. Okay.
Yeah.
Yeah. So I see. So I think now we are together.
I've gotten the point.
You've gotten the point. Thank you. Let's proceed. Let's now go to another question. So even if I was to interpret this other one, the one for 0.854, 8545. So this one tells you that the null hypothesis is that the mean difference is 0 against a mean difference which is positive. Yeah. So this one tells you for this to be positive, it means that the female minus the male should be a positive number. So what that tells you is that you are testing whether you are now testing an alternate. You are testing the null hypothesis against an alternative which says female students performed better than the male. This is what it means. So this one tells you the mean is the same against one in which the female performance is higher than that of the male because that difference is positive just from the formula here. But you notice that the p-value is 0.845 So which is also higher than 5%. So you do not reject the null. So in fact, your sample evidence informs you that there's actually no difference in terms of the performance. So I think that is clear. So you can conduct similar tests along those lines. If you want to go beyond that, then you can do the same. So if at all you are doing, this is not in the data set that we have given you, but in case you wanted to test the before and after, suppose as a teacher, you expose your students to extra tuition for a whole maybe 3 weeks or a whole month. So you do a test before they conducted, or rather they do a test before the extra tuition. And then also you look at a similar test after the tuition. So you want to compare the results before and after. Is there a significant difference in the performance before and after the tests or after the particular experiments, which is in this case, the extra tuition you give to the students? For those in the medical field, is the same thing. The rate of maybe in the disease infection before and after immunization program and the like. So there, as long as it's quantitative data, you still go back to the same point. You can now go to summary tables and tests, practical tests. Then you can now consider the mean comparison paired tests. So you're comparing before and after. So this other one you compare to, let's pick on that one. So for the second option, you want to now compare results. You want to compare performance in 2 different independent samples, the second one. So I'm giving you highlights on all of the 4 options in here. So you want to now compare maybe performance in one, in our case, you can do performance in English, performance in another subject. So you can do independent t-tests. So that's what's called independent samples. So you're looking at 2 different groups altogether. So I think that is okay. So, but let's now go to the other tests. The other tests as per the plan. Suppose you want to now look at regions. Is there a significant difference in schools across the 3 regions? So here I have more than 2 categories. So you notice that this is similar to this one. The only difference is that you have more categories. So these tests will fail. The t-test will no longer be valid. So what you will now do is that you will now conduct what's called an analysis of variance, an ANOVA table, an ANOVA test. So when you have more than 2 categories and you are comparing a given focus variable across more than 2 categories, then we will conduct an analysis of variance in what statisticians call ANOVA table. You prepare an ANOVA table which generates not a t-test, but rather an f-test. So let's try that one. So click on same place where we were. So go to statistics. So instead of going to the summary tables and tests, come to the linear models and related. Linear models and related, just right in here, you can see ANOVA and MANOVA, but click on the ANOVA and just go one way. The simplest of them all, but feel free to engage with the others as well. So click on one way ANOVA, because it gives you analysis of variance of scores across more than 2 categories. So I click on that option, then you select your variable of interest, which is scores. Okay. So the other one is the variable of interest, which presents the categories. So here we pick on the region because the region has more than 2 categories. So I click on that one as well. I choose that option. Then you can now proceed with the analysis. So you wanted some, so the other options if you can pick, let's pick this one later on, but let's just click submit for now. Let's click submit. You see the results for the ANOVA table. Click on submit. I'll come back to this one later on. So whatever you see here is a one-way. The command is one way, and then you list the dependent variable or variable of focus, and then the categorical variable. So this is what you see here is called an ANOVA table, analysis of variance. Analysis of variance gives you differences between and within groups, because you have scores. You have three regions. Remember, you have three regions: north, west, and south. So among these three regions, there is differences in scores between them. You're comparing scores between the three regions. And then you have also, that gives you what you call the between statistics. And then that's that which you call within. So you can now say within the schools in the north, there are also differences and the like. So the ANOVA table gives you this kind of a results where you have between and within statistics, which enables you to compute an F statistic. So this is not a t-test, but an F statistics, an F statistic. In the end, what you'll be caring more is the p-value right in here. So please note that the null hypothesis is still the same. The null hypothesis, let's just have it in here for the ANOVA. So the null hypothesis is that there's no significant difference in the mean scores across regions. So there's no significant difference. You can have an alternative. There is a significant difference in scores across the three regions. So you have that kind of a hypothesis that you can frame. So finally, you can then interpret your result the same way. The p-value is 74.95%, which is very high. So that suggests to you that you have evidence that you will not reject the null hypothesis. So we do not reject the null hypothesis in this case, which means actually that we are going in favor of the null hypothesis. So sample evidence indicates to us that there's no significant differences in the mean performances across the three regions. Okay, so that is what it is. So the other thing that this data gives you is the Bartlett's test for equivariances. So here, you're testing whether there is equal variation within the groups against differences, or rather there's a difference in variability between or among I take that again. So the null hypothesis says that there's no significant difference in the variances across the regions. Alternative, that means that we have differences in the variances. So here you can then interpret the p-value in the same way. So this is 0.056, which is slightly above 0.05, suggesting to you that at 5% level of significance, we also do not reject. So that is what it is. So it means that there's no variation in the scores across the regions. I think that is something you can think about. Maybe as an additional option for Stata, remember I had not closed this window before later. You can choose these are the extra statistics if you wish. They are just they give you, they give tests, or rather they test whether there is any significant differences between different groups. So it will tell you actually where the differences in the performance are. Is it in the northern? Is it in the southern or the western? So you can run either the Bonferroni test or Chaffee or CDAC. So whichever. Let's just pick on one of them. Let's just pick on this is a bit popular. Remember the other options are still as they are. We are only including this one. Let's click OK. You still get the results except maybe at the additional test for whether there's evidence in any differences in performance. So I click OK. So here you can check the results in this is the command, and then the comma is always for options. The option is the Bonferroni test in here. Whatever you have in the upper panel is what you've seen before, so there's nothing new. But this other one now gives you differences in terms of compares the scores by region. And then you will now check whether at which of these regions do we have differences in terms of the scores. So it helps you to identify which groups or which regions do we observe significant differences. So in this case, what the upper value is the test score. The number below is the p-value. So for example, you're comparing north and that one, south and that one, north and that one. So it means that you just check whether there's a difference, whether, for example, this is 1.00. That one tells you whether is there any differences in the scores between northern and southern. Come to this other one, north versus west. The other one, south versus west. So what you are looking for here is the same thing. If the p-value is less than 5%, if it's less than 5%, it shows that that is where you find significant differences. The differences come in. For example, in this case, actually all of them shows it's 100%. So it means that actually there's no differences in the mean performances in whichever pairs of regions. But let's just take an example. Suppose this value which I'm highlighting here, suppose it was 0.01 or rather 1%, and the other ones remain as they were. It will now tell you that even though the test says that there's no significant difference across all three regions combined, but there is notable differences in the performance between the north and southern regions. So that is how you would interpret that kind of additional statistics. But it just helps you to really identify where do we find differences. I think that is something for you to think about. So I want to just end here for the Stata session. You can do a lot more when you have the time. All right, now someone's hand is up. Othello, yes.
This is Daktari. I tried with you yesterday. Yes.
No problem. You catch up later after.
Yeah, this data here, which version is actually the best to use? Because I tried getting a data, it gives me 15, 11, 14, such kind of thing.
Well, we normally say the rule of thumb, the higher version, the better. But the thing is that it depends on what you want to do with it. Any software, as long as it serves the purpose for which you want to conduct your analysis, it is good enough. What I know, newer versions of software come in either improvements in two ways. One, they could have more maybe things to do. It can incorporate more models, many other things. So a higher version could have more features. In other words, for example, you could find that under statistics you could have more things here. Higher versions can also give you the same results, but maybe they've simplified the way the things are done. But if you were to have the latest version of Stata, and you run this kind of results we're doing today, I assure you there will be no differences. So it all depends on what do you want or what kind of analysis are you conducting. 11, 10, 12, whichever, whatever we've done with you, whichever version of data it would serve you. So, of course, people say that the latest versions are better, but I'll also still say but. Yeah. Yes, Paul.
Doctor, just a clarification. So we use ANOVA when we want to compare 3 aspects or more than 2 aspects.
Yes, more than 2. Anything more than 2.
Okay.
So 2, so 3, 4, 5, etc. The one that we had done here, the one that we did with you right in here, this one for the t-test, if I take you back, the one we just did, the classical test, this one for the 2 groups. You can see this restrictive.
Yeah.
If you only have 2 groups, then it's a t-test. But many a times you have more classifications. But remember, the variables should be categorical variable. You shouldn't have one that has so many categories to the extent that it might even be very complicated even for you to even see differences.
Okay.
So just reasonable number of groups. Thank you.
Thank you.
I want to help let's look at Excel a little bit so that you can compare. We're not exiting this for now, but we can still just compare things together. Let me take you back to Excel. This is the data that I gave you. In the event that maybe Stata or RIA or other software you are not able to access them, then doesn't mean that research stops. Always look for options in here. For hypothesis testing for Excel.
Hi, Dr.
Yes.
Yeah, which data set is this that you're using now?
This is the same one for hypothesis testing, the one we just had on student achievements. Are you there? The one that we just started with. I'm not changing the data set.
Okay.
Unless you just join it. Locate the data for the test scores, all that. Okay. So let's do the 2 tests. One for the mean comparison and the other one for ANOVA, analysis of variance. You can still do the same with Excel. The only difference in here is that it requires some rearrangement of the data. So it's not a bit flexible like the other one. So let me just do this because I'll be using the scores. I'll be using the gender. I want to compare the scores between the male and female students. So we want to see whether we'll get the same results like the one we had here. I'm taking you back to the one for Excel, for Stata, sorry. This is the one we did. Sorry. I think we want to see whether we could get similar results as this. This was a t-test score, a t-test for the scores by gender.
Excuse me, Daktari.
Excuse
I've noticed that the class is not being recorded. Can
it
anyone
is.
record? Okay, I'm
It
not
is.
seeing the recording. Oh, okay, so
on YouTube. Fine. It's live on YouTube. All right.
Atari,
Now.
please send the data set on the chat group, please.
Oh, right. Anyone that can have access the same. Does anyone have access to the same? One of us who can quickly get there can post the data. It's on e-learning though. In the meantime, that is a data set. I hope you can all have access to the same. So what we'll do in a moment, we'll just we'll copy this data set again afresh. We will work with a different sheet, that is sheet 2 or 3, so that we don't tamper with the original sheet, which is the data itself. So allow me to ask that once you have the data set right in here, yes, so I'm going to, it's already copied though. So let me do this. I want you to copy the 2 variables. Please copy the one for let's copy the data set on, I think someone has already shared. Thank you for sharing on the WhatsApp group. So please check. Thank you. So copy these 2 variables, just highlight the 2. Highlight as such. So once you do that, I copy. I hope we've done that. I just clicked on that for the first column and the third column. Okay, paste this in this, click on sheet 2 and then paste it here. We just want to work this with these 2 alone. Yeah, so as I wait for people to complete that task, please copy the data sets. Once you're done, let me know. Can I proceed? Yes or no?
Yes.
Okay, we can proceed. Yeah, if one person speaks, then I want to assume it applies for all. Let's proceed then. Having copied this data set, for the test in Excel, ensure that first things first, you have your data analysis tool pack. I showed you last week where that is available. So when I click on the data tab, make sure that you have your data analysis tools in here. If you don't have it, you know how to get it. Go to File, like we did it last week. Click on More. You get Options. Yeah, from the options, then you can just click on the add-ins. From the add-ins, you can go to the toolbar right in here, Analysis Toolbar, and then you go to Go.
Again, please.
Oh, okay. For those who don't have this, please install it. You must install it. So go to File, come down to Options or More for some versions of Excel. When I click on More, the other icons appear in here. Click on Options. Can you proceed? After Options, this window pops out. And because it's an Excel add-ins, you must click on the add-ins. When I click on add-ins, all the add-ins will appear here. Look for the analysis tool pack. Click it once to get it highlighted. You're done. And then you go to Go. You click Go. After you click Go, because for me it's already there, I don't have to do it. Once you do Go and then you click OK, it should come up. Done? I hope that is clear now. I proceed.
Excuse me, when you are bringing this option, the fired option, then what the data set?
Add in.
Yeah,
oh, sorry, where are you?
Add in. Yeah, it means now you already have the data pasted on your Excel sheet.
Not necessarily. This is like anytime you want to do analysis, you install it once. It means that if you didn't have it, like you can see mine in here, it means that it has not been included. So these are extra tools that you can add to your Excel. So you don't have to have this. It can be any Excel. So next time when you come, you open Excel with any other data set, this one remains as is because you have installed it. Are we done? Othello, I think yours should be okay.
Yes.
Yeah, it is. Now let's now start the analysis. For the tests, remember the gender variable has characters. These are not numerics. So first things first, you must convert this into numerics. We need to convert this into numbers or labels. These are nominal variables. So the test will not run when you have such kind of, we call them string variables. So we need to convert this into labels. So what you do is you can label them 1, 1, or 0. So choose one of them and label them as 1. So I don't expect you to do it manually by saying this is 1, the other one is 0, and the like. No. So just use the Excel functions. It will help you do it very quickly and faster. So click on Control F in your keyboard. Control F is find. Control find. I hope you have that. Can I confirm that we are there?
Yes.
Control find, and then choose the one for replace. Click replace. So you are told you want to, what are you trying to find? I want Excel to look for anything male or female, and then to replace with some label. So you are safer starting with the female, because when I search male alone, it will include all of them because the male includes the female as well. Yes, Osanya?
Yes, Lecturer, you said Control
F. Control F is find, yeah. Control find, you're finding, yeah? Finding for certain things. So let's start with the female. Let's label the females with 0. These are nominal variables. For nominal variables, the zeros, the ones, whatever. Even if you label as 10, there's no problem. It's an identifier. So once you have done that, you can now say replace all. So let's replace all. Once you replace all the females have been replaced with the number 0. I think you click on done. There are 113 replacements that have been done. I click OK. Next things, let's replace the male and label them as 1. I click on male. Change this one now to 1. These are labels. I'm labeling those ones to be 0. Click OK. Or rather, replace all. When I replace all, then there are 87 replacements that have taken place. So 87 plus 113 makes 200, which is what I'm looking for. So I can close all this. So all the variables which were string variables have now been replaced. So what you can now do is now organize, because the whole point, for Excel, if you are doing the data set, you must separate. We must separate scores. You must do scores for female and then scores for male. So for you to do the test, you must separate all the scores in that way. So I want to list all the scores for the males and the females. So what you now need to do is to sort this.
Excuse me, Dr. How
Yes.
did we get to the G to become male?
Othello, I thought we were doing this with you. How did we get what?
G, the G becomes male when the score, where we are talking about the score F, then for female, then we got G for male.
This one.
Or
Are we
just,
here?
they have to follow each other.
No, not necessarily, not necessarily.
Okay.
But do you have the ones and the zeros? Do you have this one,
Yeah.
Othello? One?
Yes.
Then this is it.
Yes.
So what I want to do now is all the 200 of them, I want to separate the scores for the female scores and then the male scores separately. But you see right here, it's a mixture. So what I now need to do is to sort this. I want to sort them by gender. So let's highlight all these two variables, the two of them, everything up to the end. Highlight this up to the last observation here. So we want to sort them. Remember, you're highlighting all of them from the scores to the gender, the two variables. And then you look for the sort. You look for sort. Where's the sort option for you? Just look for sort. Click on data. When you're on data, there's a sort A to Z. Are we done? Click on it. When you click on it, you want to sort the data set. You are sorting by what variable? So click on choose the option you are sorting by. So I click on this one, I want to sort by gender. I hope that is clear. It doesn't matter whether it's the smallest to the largest or the largest to the smallest. It doesn't really matter as long as I've sorted by these variables so that I have the zeros first or the ones first. Are we done with that? After you're done, you click OK. So there, all the males have been, was it the females first, which have the label 0, and then the males later. Good. Now, what you
So,
now do,
once again, we sort by the score
gender,
or the gender?
Gender. Sort by the gender, because we want to separate the scores for the two genders. For those who are following me, you can then we can then flow in together. I want you now to copy all the scores for the females, the ones with label 0. Just copy the scores now only. Copy all of them up to where the 0 ends. Where the 0 ends is number 114. Remember, the labeling is 0 here. So it means that from 115 going down is the scores for males. Please copy that as well and paste here. So I've copied all the scores for the females. Let's copy the scores for the males. You can see the scores for the males begins from 10.5 up to the end. I'm copying that as well. I want to paste it in this way. It doesn't matter, you paste it there. So this is what I wanted. This is what you want, because you can now perform the test because you have one data set which is different from this other one. So you can see for Excel, it's a bit, there's a bit of work that must go in before you do the test. Now, I think from here, you can, even if I ask you to run the test, you can now run. Good, now let's do it formally. Let's go to data analysis. Click on data analysis. Okay, from the data analysis, just go right down there, you see t-tests. Let's pick the one for unequal variance. You want to now compare the scores for the two groups, assuming unequal variances. Have we done that? Once you do that one, you click on OK. Click OK. So this window is for you to select the variables. Now you now need to select the data sets for the first variable and the second variable in that order. So you select by clicking on the arrow. So let me collect the data for the first variable by clicking on the first arrow here. And you click it once, that window shrinks. Then from there you can now select. You can start with the variable name score for females. You can pick it down up to the last one. Once that is the case, you click back the arrow because the dataset has been selected. Click back the arrow. I now select the second variable in the same way, which is now the scores for the males up to somewhere there, up to 7.5. Click back the arrow. Hopefully you're done. Let's go to this next thing, hypothesized mean difference. These are now the null hypothesis. The null hypothesis says the mean is 0.
Kindly allow us to finish a bit.
Okay, let me give you a second to catch up with me.
Daktari, excuse me, I got lost when you picked data analysis, when you selected data analysis.
Okay, no problem, we'll repeat. Data analysis?
Yes, when you clicked on data analysis, I got lost there.
Are you in this window?
Yes, I'm here.
Pick for the t-test and equivariance.
T-test to
assuming an equal variance.
So, okay.
Click OK.
I've done that. Yes, I'm there.
Then you now select the variables in any order. Start with the first variable one. Click on the arrow. Are we there? The window shrinks and then you select the first variable, which is this one. Select everything from the beginning till the end. Once you have selected the first variable, you hit back the arrow. You select the second variable in the same way, which is now the second column. Click on the arrow for selecting the data. Click on highlight the data, including the label, the variable, the label given to it up to the 7.5. Click back the arrow. So ensure that this window or this option is populated with these cells. We done? Please put the hypothesized mean value in terms of the differences to be 0. This is now the null hypothesis. You are saying that the mean difference is 0. In other words, the mean scores for the males and the females is the same. Are we done? Once you put your value 0 there, click on the labels because your variables, you have included the names of the variables. You must click on the labels because when I was highlighting the data, if you can remember, I highlighted the data labels. The last thing before you click OK is you select the output range where you want the results to appear. You must choose the option for output range. From the output range, you select the cell you want the data the results to appear. Click on the arrow, and then you pick on any cell. Let me just put it right at the top somewhere here. Pick any cell, doesn't matter which one. Just select it once, and then you click back. So ensure that your options are well chosen. Nothing is left up to there. So click OK. Once you are done, click OK. Good. There you go. Now, so this is your t-test scores or results. So the null hypothesis is the hypothesized mean difference is 0. We have degrees of freedom there. So what you should care most is not really, you just want you to say whether are you conducting a one-tail or a two-tail test. That's the first thing you need to ask yourself. Are you conducting a one-tail or a two-tail test? So as you've spoken earlier, if you're doing a one-tail test, and I hope you know what a one-tail test is. First off, if you're using the traditional method, you'll be comparing the t statistic right there. This is like the computed value for t-test. Compare that against the critical value, t critical. If you're doing a one-tail, you compare this and this one. Or if you're doing a two-tail, you compare the same t statistic in here from the data against the other one from the two-tail. So you choose which one you want to interpret. And I think I had not emphasized this for now, but if you, in case you intend to use this as your criteria for selecting or rejecting or not rejecting, then you compare this and this one and say whether is there evidence for you to reject or not reject another hypothesis. Ideally, if the computed t statistic, this value of negative 1.05 is higher than the critical value, then you reject the null. If it's higher than this in absolute terms, so you can see 1.05 in absolute terms is smaller than either of these two. So it means that you do not reject the null. But otherwise, if it were higher or it was bigger, then you could have rejected. But as I told you, utilize the p-values. The p-values are more informative and direct to interpret. If it's a one-tail test you are conducting, interpret the p-value of 14.5%. If it's a two-tail test like the one we were doing, you can now interpret this 0.291. And you see for sure that the p-value is 0.291, which is higher than 5%. So because it's higher than 5%, you do not reject. Just wanted to see whether this result of 0.29 compares with what we had done earlier in Stata. So you go back to the Stata output we had done. Yes, I hope you can see this one. That is 0.211, 2911. Same thing. This other one was the one tail, 0.144. And that's exactly what you see here. So you see, whichever way the tests will always return the same conclusion. I think that is fair enough. That is something you can do. Okay, now let's just do the last. I hope it's clear. Can I get any question if there is? Is there any question up to there? I think we are good. We are good. So you can call this one t-test if you want. Let's do the last one, ANOVA. This is the last one. Yeah, so we just do the ANOVA in the second sheet. So I want you to note that for ANOVA table, we want to replicate the ones we did in Stata, which is this one. Whether we get the same results as the one we had done. So the process is actually the same. The process is the same. Let's now go to, let's copy the data set once more. I hope we are together. Can I proceed? with ANOVA. This will take us less than 5 minutes and we're done.
Yes.
Okay, let's go back to the data set. Let's now select the scores again. Click on the arrow right in here, click it once. And then let's also click on the region. Good. Yeah, so I'm copying. Right click, copy. Let's paste. Let's paste that way. So the data is there. I want you to do the same thing as we done earlier. Label the north, west, and southern with whichever label. So click on Control F. Control F. Then from there, replace. So let's even leave the first one as north. Let it have a label 1 and click replace all. I want you to replace the north with 1. There are 82 replacements that have happened. I said, okay. Let's replace west with a label 2. Let's remember the labels are not really anything. I told you can use any, but I'm replacing the west with number 2, replace all. 55 replacements have happened. And then for the last category, label 3, this is south. Give them a label 3, click OK. 63 replacements. And now close this. Now I want you to, as an exercise, or rather the last thing you can do, get the scores for the north. Get me the scores for the other regions, for the west, and get the scores for the south. Separate this. Get me the scores for the northern candle, this other one aside, the other one aside. See whether we will have something. So just highlight everything and then you sort. So I'm highlighting scores and region up to the end. Up to the end. I've highlighted the whole thing. Click on data. Having clicked data, choose sort. You're sorting by region. And you click OK. So done. So I've actually rearranged the data set, starting with the 1s, followed by the 2s, followed by the 3s. So finally, let's copy the data again. We are now copying the numbers only. So this is a bit fast because we did it before. So I'm highlighting up to the end of 1s. Do it very carefully and accurately as well. This is what you get. Up to 83. I'm copying that one. I want to paste it here. Get for me the number 2s, paste it there as well. From 84. 84 all the way to number 138. I'm copying that as well. I want to paste it in the second category here. Finally, number 3 for the southern region. Go back to the data set, start somewhere, 139 till the end. That's what you get. Copy, let's paste that. So you have finished preparing the data for the tests. So ensure that your data set has something like that. And the good thing is that I hope you're noticing that whether you have few categories or few observations in each category, there's no problem. Good. I think we are getting there. The final one is to run the test. Please go to the same data analysis. I'd like you to try it out. Good, so let me go to data. Data analysis right in here. Look for analysis of variance to be among the first ones. ANOVA single factor. One way ANOVA, that is. Once you had done with that one single factor, click OK. After that is done.
Excuse me, Malemu.
Yes, please.
Yes, going to ANOVA single factor, how is that determined, please?
How is it determined?
Yes.
In terms of, what we were doing is, for you remember we are comparing mean average performance over different categories. When I say single factor, it is simply one way. In other words, you are concerned with you're not looking at 2 or 3 variables at a go. You're just concerned with a single variable, now comparing the same variable across factors. So that's why it's called a single factor. It's not necessarily one that is complicating. Eh? I haven't tried the other one.
That is the score we are now trying to compare in a different categories.
Correct, because all these we are seeing as scores.
Okay, thank you.
Only that they have been categorized into 3. So that's the reason why you have that categorization. Once you've done that, then you click OK. So for ANOVA, you see you only have one option for selecting the data. Unlike the other one, you're doing one by one. This one, you have to input it once. So I must click on the arrow here. Before I click on it, this tells you one thing. It tells you that the data set must be following each other in terms of the cells. This is in FGH. So if you have space in between, then the test you will be confusing the process. So let's click on the arrow, and then you highlight the entire data set all the way up to where the last data set is appearing. You can see we have a longer series for the first category, up to 83 or 82 for that matter. The other ones have even shorter ones. So, but they are all highlighted. So don't worry if you have unequal groupings, doesn't matter. So, but we must highlight the entire group. Once you've done that, you click back to the arrow. So you can see the groups are in columns, which is what you can see. First column, second column, third. So the column 1 is highlighted. If you add them in rows, then you click rows. But for now, we have columns. Let's include the labels in the first row because the first row has names or the labels for the variables. Let's leave 5%. This alpha is the 5% level of significance. And then you click on the arrow here for the output range where you want the results to appear. Click on it. And then you select the cell you want the results to appear. For my case, I'm just going to paste it even there. Any place and click OK. So for now, we're done. You're now done. You can now hit OK. I'll be the last one to hit OK. Hopefully you have results. I hope you have results in here. Click OK. Then you have some numbers to work with. So this now gives you the analysis of variance tab. So if you can check what we did last in Stata, we had between and within variation, and then focus on those two. Importantly, I'm concerned with the p-value. Those are the main things of concern. If you're using the F statistic, you can compare F value from the data against the critical value. This is a critical value. If you're using a F statistical table. But for us, let's look at the yellow one, the p-value. Hopefully you can see that it's not very different from what we had done earlier. So it now tells you that the p-value is 74.9%, suggesting to us that we will not reject the null hypothesis that there's significant differences between or among the groups. So the same thing we had done earlier. So just wanted to confirm that you have the same results. For the ANOVA table, I think this is what we got. The F statistic is 0.29 and the p-value is 0.7495. And this is exactly what you have. And this is 0.29. So you see, irrespective of the tools that you're working with, you can still conduct your analysis as such. Okay, good. Good. Now.
So, Daktari,
yes.
When you're rounding it off, do you use the 4-digit or 2-digit? Because I can see in the other one we had four digits after the decimal.
Okay. This decimal. This one you're free to it depends. Personally, I would prefer 3 decimals if that is what it is. You could go with 3, but I would discourage that I would not prefer that you over round it off. Because sometimes rounding off too much also you lose some degree of accuracy, especially when you're comparing between results. Sometimes that small difference is what you could be looking for. For example, in Excel, you can see in Excel you have even very many decimal points. For example, this one is 0.2889, but you can see the actual number is this one. The decimal points run even up to the, I don't know, 12 or whatever. They are quite a number. So 0.289, fine. If you are using Stata, you can even see Stata has given you up to 2 decimal points.
Yeah,
so
that's the reason why.
That's
why I asked, because for Stata gave us 2.9.
Yes.
Is 2.9, and then the other one was giving us 2.88 something.
Yeah, it's okay. They think as long as you are within the neighborhood, then it's okay. So that means that for Stata, it's designed in a manner in which the tests are rounded off to 2 decimal points. You can see even this one. Most of them are rounded off to, yeah. So depending on which tools you are using. So here, if you are reporting in Stata, then you go as per what is recorded here.
So it doesn't affect the reliability of the data and validity.
No, it doesn't really affect the accuracy. Actually, the word there is accuracy, the accuracy of the results. But if you are working with Excel and you see your data is reported like this, reporting 0.29 is not bad. It's okay. Reporting 0.289 is also okay. So just feel free, but I would be very careful rounding it off to 1 decimal.
Okay, thank you.
Good. Before I let you go, please let's go to the original data here. I wanted to introduce something else. I want to see whether this is the data we copied. Okay. Let me do the last thing, which is regression. This I repeat. Let's just recap on regression. And what we want to do is, let me just copy everything. It's no problem. Let's just before you copy, let me select. Let's select carefully. Let's pick on the scores. Let's pick on that one for households. Let's look on gender and language. By the way, let me remove this. I just want to just demonstrate one thing only. Let me have those 3: scores, gender, and language. Just make it simple. Scores, gender, and language. Copy. I'm copying the 3. I hope you're seeing the way I do copy. I point to the arrow so that I copy the entire column. Let me use those 3 in the regression. Click back on go to the regression tab. I want to paste it on the first cell. There we go. I hope we're done with that. Okay, the next thing you can do, let's replace this one's the gender with the ones and the zeros. Control F. Replace. Just repeating what we had done earlier. Let's start with the female. We had labeled them as 0. Females 0. 113 replacements. Males 1. We're just repeating what we had done earlier. So I wanted to just remove those characters so that I have numbers. So I hope you notice that for regression, you must work with numbers. You must work with numbers. Good. With that, I want to see whether changes in the scores for English languages or the languages affect your average score. I think this is something one can be able to explore. Does the language's performance affect the overall score? And then we also ask another question, does gender matter for the average scores? So you can do your regression model even as. So let's go to, as the last thing, this is the very last one. Data analysis again. Click on data, go to the data analysis. From the data analysis, please look for regression. Go back to the regression, it should be somewhere here. Regression is here. Click on OK, click OK in here. Done. Let's input the dataset in this regression model. Click the Y variable, which is a dependent variable. Your focus variable is score. So I click on the arrow. Let's click on score all the way to the last one, 200. Once you've highlighted, click back the arrow. Let's input the X range, independent variable or variables. Click OK, click the arrow. So for this one, you must select them together. So it means that they need to be together. I'm highlighting the two columns till the end. Done up to there. Click back the arrow. Let me give you a minute to catch up with me. Few seconds. Good. Next thing. Click on labels. Click on the output range where you want the results to appear. And then let's select the cell you want the results to show. So let's just pick anywhere, even there is still okay. I click on back the arrow. So let's populate as such. And then once you're done, please click OK. We did this already, so it's not a complicated task. Click OK. Good, there we go. So I think you have some regression coefficients, which I think you can interpret. First of all, you have your multiple the correlation coefficients, multiple correlation or multiple regression, it's actually the multiple correlation coefficients. We have the R-square value, adjusted R-square value, the standard error of the regression, the number of observations at 200. We have an ANOVA table right in here. Then the regression coefficients are what we wanted to look at. So the independent variable is scores. Independent variables are gender and languages. So those are the independent variables. The coefficients are as such. The p-value is that one for gender. For the other variable, for the languages, that is the coefficient 0.229. The p-value is that one. Good. So the question is, does language performance predict the overall mean score? That is what you look for there. The value I've highlighted. That is what you'll interpret. So tells you the effect.
Excuse me,
yes, please.
How do we interpret now after we have gotten the result? How do we interpret this now?
Okay,
how
that's
do we
what
now go on to say what languages, what role the languages play in the score?
Yes.
Value? Yes.
Okay, good. First of all, then, when we had the session for regression, there are a few things you need to look at. First of all, you've identified your variables. The dependent variable is score, which is what you want to predict. Then using these two predictors, gender and language. So we can just let's talk about each of them. This is the coefficient for language. First things first, ask yourself, is it a positive or a negative coefficient? The answer is a positive. It tells you that an increase in the scores for language is associated with an increase in the overall mean grade. Because it's already a positive, so you are associating those changes to changes in the other. But if you want it to be more statistical and more precise in the interpretation, then you can actually say that for every increase in the language average by 1 point, okay, there is a resulting increase in the overall score by 0.229. Now that is now if you want to now give it the true meaning, this score tells you that for sure, if the average, or rather if the language score rises by 1 point, because these are measured in points, because either you're on 1 point, 2 points, up to the 12th point. So it means that for every increase in the language performance by 1 point, there is an associated increase in the overall score by 0.229 points. Furthermore, you can see that there's a t-test associated with that, which also generates an associated p-value. So you look out at the p-value. The probability value associated with this coefficient is this number you can see here, which I hope you can see that this is a number written in standard form. Yeah, someone will say, what number is this one? As long as you see E there, it is 5.87 E-06. In other words, that's the same thing as, let me just take it again, 5.87. So that's like 5.87 multiplied by 10 raised to minus 6. In other words, you go 6 decimals points back. So that's like 0.00000587. I hope that is 1, 2, 3, 4, 5, 6. No, that's more. So I need to remove 1 point there. So that is 0 point that. So that value is actually 1, 2, 3, 5. No.
Not really, Daktari.
What's
the
your
other way around.
Correct. Yeah.
Supposed to be this way. Yeah, good. That is what it is. So that is what it is. So what that tells you is that this value is so small. It's even smaller than 5%. So it tells you that the language performance has a positive and a significant effect on the overall score. So you can now see that I've looked at the sign. It tells you there's a positive or negative effect. I've looked at the magnitude of the impact, which is 0.229. I've also assessed whether it's a significant impact or effect. So you look at that from those three perspectives. Please, for this case, I will not expect you to interpret the intercept because it doesn't make any, it's not reasonable. Because you know what the intercept is about. It tells you that when these others are zeros, which is not even realistic, the average score is 6.2. But anyway, that's a story for another day. Let's look at the one for gender. Is there anyone who wants to attempt this one? Because gender has a positive, is associated with a positive effect on the average score. Okay, I want someone to see. Yeah, Janie, let me see.
Let me try.
Yes.
I think for every increase, for every change, is it? I don't know whether to use change or
yeah.
Okay, for every 1 point increase in but now this is gender.
Yeah,
So
actually, nah, but this is gender, yes. I like the way you're asking your question.
Yeah, my thinking is now we can't talk about increase in gender. So I don't know. But I'm saying there is a positive effect. There is a positive and a significant effect because the change is positive. If I start from there, it's
we agree with you.
Yeah, it's 0.2755 that value. But now what's changing? Is it the gender?
Now we'll answer that. Let's answer for me the one for significance. This is
there's that level of significance is relevant. It's significant because that is 0.168399.
What percent is that?
That is 16.83. 16.84%.
16.84%.
Yes.
So is that significant or is not significant?
I think that is significant.
You think that is significant? How about the one that we did here? Yes, I'm taking you to task because I want you to understand where we are. Exactly. The one we had done earlier sorry, is this other thing? This other one for languages, we said this is 0.00000587, and we say it was significant.
Okay, then 16.84 is not significant.
There you go now. And I wanted you to realize that.
Yeah, okay.
I think we have, okay, thank you for the attempt. Very good. So you have a positive effect, and also the effect is not statistically significant. Let's use the language, statistically significant at 5%. Let's use that language in the interpretation.
I just still have a question.
Yes.
How would we interpret the gender part? Yes. Because in the languages, we're saying for every 1 point increase in problem that's caused in the languages, then would bring about an increase of 0.2295.
Correct.
That is now where you're considering the performance in the language. But now when we're looking at the gender, what are we putting into consideration? Is it whether it's a boy or a girl, or I don't know? What are we looking at?
Oh, nice. I think this is exactly why I brought this regression bit today. Because I know we had done it earlier last time, but I wanted it to bring this a situation where you have a variable such as that. First things first, let me then guide. But thank you for the input. So I want you to look at what we had done here. We had these two labels. What did we label for each of them? Male?
Male.
Was it 1 or 0?
1. No. Female was 1.
Mm-hmm.
And male 0.
Like that, I hope so. Well, let's assume this was the labeling.
Yeah.
We may have done it. I thought it was. I think it was the other way around. Oh, yes, yeah, you're right. It's like this. It was like this. I remember. Now, what you need to do is that when you're interpreting a variable or result such as this, you must first of all understand how you labeled your variables, right? So means therefore this variable, because it is only restricted to 0, 1, then you should not talk about increase or change, just like you had alluded. So I wasn't expecting one to say that increase in gender by 1, because gender is not, it is not a continuous variable. It doesn't really have any change over time. It doesn't change over time. So there, what you do now is that you interpret this in terms of comparison. You're comparing the results in the male versus female.
Okay, that makes sense.
So if the value is positive, like you can see here, then it means that it shows that the one for males is higher, because the variable that you have labeled 1 is assumed to be your reference point. So you're making reference to the male. So there, and then you compare with that of the female. So this means then you could say that in this 0.275 could be interpreted as the performance, or rather the mean average point for male students is 0.275 higher than that of the females. So that is how you do the interpretation, because it is a different variable, unlike languages. So you make reference to the other one, but you should know which one has been labeled as 1. If this was a negative, if this value was negative 0.2, then you will now do it the same way. It means that the performance of the males is 0.275 lower than that of the females. It's like now you turn the interpretation around. So I know many a times, most of us in your various fields, education, communication, you often meet variables such as this. And at times you struggle interpreting. So it offers you a way of comparison. I hope I've answered that question. And I think that was the whole point. I wanted to introduce regression analysis at this stage. Perfect. Anything I need to hear as we do the wrap up? So you have a lot of things to do and talk about today, and we've spoken a lot. I didn't expect it to be this long, but it's okay. Any questions I need to respond to before as I release you?
Just worried, Dr.
Yes.
Just worried. Any expectations on the final term paper? Like what do you expect from us?
Not quite. I think I've already, the instructions I've given you in the term paper. You all have it. So I want you to, work on it individually. There has to be evidence that, we should not have evidence that so-and-so's work is different from or is similar to another person. So I want you to work individually, first of all, And then after that, you should be able to now do your reports in a format that suits you in response to each and every question.